Right now, your brain is processing the exact pitch and rhythm of my voice without you even having to think about it. But out here in the physical world, sound is nothing more than invisible ripples of kinetic energy displacing molecules as they travel through the air. The human brain operates entirely in the dark. It cannot comprehend physical air vibrations because it strictly processes information via electrical impulses. To make sense of the world, your body has to cross this massive gap, taking raw, airborne kinetic energy and converting it into a biological electrical signal. The human ear acts as a highly specialized bioacoustic engine. In a fraction of a millisecond, it catches that energy and translates it across 3 distinct physical states. The first point of contact is the outer ear, or pinna. Its curved structure operates like an acoustic funnel, designed to catch gaseous airwaves from the environment. Once captured, those waves travel down the ear canal until they physically collide with the eardrum, forcing the thin, semi-transparent membrane to vibrate. That collision instantly transfers the kinetic energy from the eardrum directly into the middle ear. This animated diagram shows the 3 smallest bones in the human body: the hammer, anvil, and stirrup. Notice how they interlock to form a precise physical lever system, where the force applied to the first bone is multiplied by the time it reaches the last. The primary job of this solid bone state is to aggressively amplify the weak kinetic force of the original airwave, packing enough punch to push into the much denser inner ear. The final bone in that chain, the stirrup, pushes forcefully against a snail-shaped structure known as the cochlea. This marks the transition from solid to liquid. The cochlea is completely filled with clear fluid. As the stirrup pumps against it, the mechanical pressure creates physical, moving ripples that travel through its internal chambers. Suspended directly within this fluid is the organ of Corti, a structure housing a specialized array of over 15,000 microscopic sensory receptors, known as hair cells. In this unrolled cochlea cross-section, hair cells act as a frequency sorting mechanism. High pitches agitate cells near the entrance, while low pitches travel deep into the spiral. As fluid pressure bends these cells, the mechanical stress ignites tiny electric sparks at their bases. Those newly generated bioelectric pulses are fired immediately up the auditory nerve and routed directly into the brain's auditory cortex. Through this exact sequence of physical states, from gas to solid to liquid to electricity, raw atmospheric pressure is finally registered by your mind as a recognizable sound. Extreme biological precision comes with extreme fragility. Because these microscopic hair cells are so highly tuned, they do not regenerate once destroyed. Exposure to loud noise acts like a physical storm inside the cochlea, permanently snapping delicate hair cells. Severely stressed cells become stuck in a bent position, constantly misfiring phantom electrical signals to the brain. This creates a persistent ringing known as tinnitus. Hearing loss and persistent ringing are often treated as inevitable signs of aging, but they are actually the result of literal, permanent mechanical trauma to the ear's delicate energy translators. Preserving your auditory health starts with the 60-60 rule for digital audio. Listen at a maximum of 60% volume for no more than 60 minutes at a time. If you are entering a high-decibel environment like a concert or a construction zone, wearing physical earplugs is a mandatory shield. Never insert cotton swabs or sharp objects into your ear canal. Doing so packs wax deeper and carries a high risk of rupturing your fragile eardrum. This intricate translation machine operates 24 hours a day to anchor you to reality, and it demands lifelong respect. If this breakdown helped you understand your hearing, hit the like button, share this with someone, and subscribe for more.